Life has to be valued. Life has to be lived. But how can we live when threats are just a step away? One of the most alarming diseases is rabies, due to its 100% fatality and lack of available treatment.
So rabies is a disease that's caused by a virus which travels to the brain through the nervous system. The virus is transmitted to both animals and humans via bites or scratches of rabid animals, and 99% of human rabies cases is associated with dogs.
Public health authorities are now devising strategies for rabies prevention with the collaboration of local scientists and government agencies.
So the STOP Rabies program is a synoptic study on transmission and optimum control to prevent rabies. It is an initiative that uses science-based evidence to formulate strategies which can eventually help achieve a rabies-free Philippines, with Davao City as a case study.
The STOP Rabies program is a research grant by the Commission on Higher Education, Discovery Applied Research and Extension for Trans Interdisciplinary Opportunities Grant in Aid, in collaboration with the University of the Philippines, Mindanao, Davao Medical School Foundation, Davao City Veterinarian's Office, and Davao City Health Office. It is composed of 4 projects with specific objectives.
So in this study, we want to look at how the virus evolves and spreads within Davao City.
Our objective is to model the long-term rabies incidence in Davao City. In order to achieve this, we will develop and analyze mathematical models, take into consideration some hypotheses about rabies spread in the presence of control interventions such as vaccination, registration, impounding, and attendance in educational campaigns.
So our part is to evaluate these programs by looking at the antibody levels of those people who have been given anti-rabies vaccine, both as pre-exposure and post-exposure.
What we're doing is we translate all of these findings from projects 1, 2, 3 for policy, to make policy papers so that it will be of interest to policymakers, and then they'll be able to understand more clearly what our findings are.
This is a brave step towards a more defined strategy, a step that integrates empirical evidence and scientific analysis that are vital in delivering effective public service.
By studying the sequences of rabies viruses from local dogs, we found out that there are genetically related groups of rabies viruses that are randomly distributed throughout the city, which means that the virus probably hops from one area to another. In fact, we were able to trace the movement of the virus, and it appears that dog movement, which is facilitated by humans, seems to play an important role in the spread of the virus within the city.
We hope to see from our analysis that rabies would tend to spread in districts with highly population density for dogs, or to places where transmission of rabies is more likely. The models will also allow us to determine efforts we need to do in order to keep rabies from spreading, thereby lowering rabies incidence.
This project that I'm leading is basically geared towards making sure that people understand what the findings are.
The community of experts from the fields of biomathematics, economics, human health science, and veterinary medicine, together with government agencies, will work hand in hand to provide us with a blueprint that is both substantive and promising for a rabies-free community.